All right, so one of the fundamental ideas in algebra is turning language into expressions that we can manipulate inside of equations. So I've got 3 examples here: 8 more than some number, 3 times some number, and 1 less than 2 times a number. So our goal is to turn those 3 statements into an expression that we could then manipulate inside of an equation. So the sum number piece, this right here is what we're going to represent as n. I'm using n because n and number. Other unknowns that you'll see used are x, y, m, p, q, all sorts of unknowns you can use. It kind of depends on the context. Since it's some number and number starts with n, I'm going to use the letter n. I want 8 more than some number. So I've got some number n, and I want it to be more than, but how much more? 8 more. So that's n plus 8. This next example, 3 times some number. Okay. Well, again, I've got some number. So there's my unknown, and I'm going to use n, but I've got 3 times some number. 3 right on the front there. So 3n, and in case you've forgotten, when you just stick a letter and a number together like that, what you're saying is 3 times n. So this is the same as 3 times n. But it's much easier to manipulate an equation when we use this form. So get used to seeing 3n as 3 times n, or 3 times some number. Okay, and the last one, again, we've got a number, so I'm going to use n for this part right here, some number or a number. But what are the conditions? We've got 1 less than 2 times. So let's write that number n, and then let's put some stuff around it that'll make this true. 1 less than 2 times, well, I'm going to show 1 less by taking 1 away from n, but it's not just n, it's 2 times n. So I've got 1 less than 2 times n, 3 times n, and 8 more than some number n. So this is a really generic word problem that you might see. Mary spent $4 more than half the cost of a bike. And if we wanted to write an expression to represent this situation, we need to note a couple of things. 1, Mary spent $4 more than half the cost of a bike. So we want to represent, we choose a variable or an unknown or a letter to represent something in the situation. I see 2 good ones. We could either use a letter to represent cost or a letter to represent bike. I'm going with cost. Doesn't really matter. I'm just going to write that C right down there. And now I'm going to look at the other parts I underlined in red. She spent $4 more than half the cost of the bike. Well, how do I show $4 more? I add 4 on. How do I show half the cost? Well, there's 2 ways. I can divide only the cost by 2 and not the $4 more, or I can multiply the cost by 1/2. And another way to show multiplying the cost by 1/2 would be to write the 1/2 out front. So there you go. $4 more than 1/2 of the cost. Now, it's important to understand that this is the exact same thing if I chose to use B for bike. The important thing is not the letter we choose to represent, though that can help us keep things straight. It's keeping the expression correct. 1/2 the cost of the bike plus 4. And maybe it helps us to say that here that B is equal to bike, or that C is equal to cost. So all we've done is we've taken this sentence full of words and turned it into a simpler expression with numbers and an unknown. So learning how to translate between English and between expression, mathematical language, is really the foundation of algebra. The better you get at this, the better you're going to do in this course. All right, and let's look at one last case. Let's say I've got here a rectangle, and I'm going to split it right here, And just for fun, I'm going to shade this whole part this kind of muddy color of red. So we know that I've got two sections of this rectangle. This rectangular looking piece and this taller, more squarish looking one. I'm going to shade that blue. Let's say I know the entire rectangle that I'm outlining right now. Let's say I know that entire rectangle is 8 units tall. And let's say I know that the red section of the width, let's say I know for sure that this is 12 units long. But that 12 units long is only covering the red section. We don't know how long the blue section is. So I need a way to represent this portion of the length. So I'm going to come in here and I'm going to use a variable. I could use x, y, z, m, n. Since this is, let's see, we do height and width, let's put a w right there. Doesn't have to be a w, I'm just using a w because we're kind of, in context, we're talking about width. So it makes sense. Now, there's some questions. Now that we've represented this situation, the height is 8, this was a given. The length of the red section was 12, that was also a given. But then we went in here and assigned a variable, or rather an unknown, to this missing length here so that we could do some manipulation with it. Now, let's say I wanted to write out the dimensions of this entire rectangle. Well, I've been given the height is 8. That was given from the beginning. But what about the length, or I guess the total width, or the total length of this side here, the black section that I've just drawn? How long is that? Well, we've got a 12 and we've got a W. We've got a 12 and a W, so we're going to write that mathematically as W plus 12. So we've got an expression for the length. The length is equal to W plus 12.